Today we want to continue with our brief definition of the inverse function. For a function to have an inverse, the function must be 1 to 1. And so let's assume we have our domain. Let me draw this well. Let's assume that we have our domain A and our range B, and we have some elements of the domain mapping to the range. Now we see that every element of the domain has a unique image. And so the function, if this function is defined by f of x, our function is 1 to 3, 2 and 5, and 3 and 7. And if we want to get the inverse, then the inverse function, as we already know, just reverses the function, the original function. So it becomes 3, 1, 5, 2, and 7 and 3. It is very important that the original function is 1 to 1 in order for you to get an inverse of that function. If the original function is not 1 to 1, then you cannot get the inverse function. And I want to briefly explain that. Let us assume that you have this function where you have 3 and 2 both mapping into 5. Then when you write the function becomes 1, 3, 2, 5, and 3, 5. This is okay, this is a function. But when we write the inverse function, you see that the inverse function becomes 3, 1, 5, 2, and 5, 3. The inverse function must also be a function. But in this case, we have a domain of the function having different images. And this cannot happen, because what we are saying is that an input or an output that is meant to produce the same input now in the reverse order is now producing two different inputs, and this cannot happen for the inverse function. And so if the function is not 1 to 1, we cannot have the inverse. Now, one definition of the inverse function is that if you have the inverse function and you apply it compositely on the function itself, you should get x. And so, for example, let's assume that you are asked to show that x minus 3 over 2 is the inverse of 2x plus 3. Now, if this is the inverse, then when you take the composite function, you should get x. And so all you are going to do is that you apply the inverse on the composite, on the function 2x plus 3, and this becomes 2. Now our x is going to be replaced by that. And so 2, instead of writing x, we are going to write x minus 3 over 2. And then we have plus 3. And this 2 cancels that 2. We have x minus 3 plus 3, which is 6. And so we conclude that since f inverse of f is equal to x, it implies that x minus 3 over 2 is the inverse for 2x plus 3. This is the end. See you later.